please.
Okay, good morning. Since I'm the last thing that stands between you and the lunch, I will try to keep the time and hope I will be able to say all I wanted to say. So I will talk about some of the things that you actually have heard about, but I would like to look at it from the point of the MetaNet project and just highlight some of the best results that have been achieved so far in our project. But also, you will see there are many links to the other projects that have either been mentioned by Josef or just in the previous talk. So I will show 4 areas in which the MetaNet project is working, or its research part, and then I will also talk about some links to the other projects and some of the future that we have planned within our project. So first area in which research is going on is adding semantics to machine translation. Now, this is obviously nothing against Moses that we have just heard about. Of course, if any of these areas, not just the semantics part, but also the others, become successful, we hope we actually will be able to put it as one of the modules into the Moses system as such. And in fact, we locally at Charles University are working on actually implementing one of those systems that use semantics into Moses. So the first example of adding semantic elements into translation is to do anaphora resolution. And the reason is that, for example, in German and many other languages, and of course all the Slavonic languages as well, if you want to use pronouns, you have to know often the gender, but sometimes you also have to know number and sometimes even more information to translate this correctly, because in English, if you say it could be translated in many different ways. So one of the things which can help is to actually resolve what the pronoun is referring to, and then use the information from the referent in resolving the ambiguity. So this is just one example when you want to translate into German this short section of a text. If you can infer that the its refer to hospital and then they refers to doctors, then of course the pronouns in German can be resolved relatively easily. There will be a report on a system which uses this type of anaphora resolution at the WMT workshop, which is one of the things that the Eurometrics project is organizing in this a month from now in Edinburgh. The other possibility is to actually do not just anaphora resolution, but try to resolve many of the semantic relations that are actually present in the source text. And one of the systems that is doing just that, it's the so-called Hajic.wmv system, which is trying to analyze the input sentence in full swing, both in the syntactic and semantic relation part. So what we have achieved in the first year was another improvement in the automatic metrics, which and the graph in the right hand side of the slide you can see actually shows that the systems between 2010 and 2011 have improved all. But in fact, the system that uses the semantic analysis has improved a little more than the others. So we hope that eventually we will be able to come closer or even surpass the best systems. The improvement was just 0.6 blue points, but when we do the subjective evaluation, as it's always done at the WMT workshop, then in fact the semantic-based systems are usually better, or at least they show more improvement than just the automatic metrics. Simply people like more systems which do less semantic-based errors than sequence n-gram-like errors. And again, those systems will be reported on at the WMT in Edinburgh. This is another example, a system that was done in Aachen, which actually goes in a very similar direction. It uses dependency analysis and also the lexical relation between words in the dependencies. And again, you can see that here even the blue score improvement was quite large. Another area that's being worked on, usually which is being worked on and has been in talks for a long time, but only within this project, people really took the challenge and start looking into all the types of possible solutions, is what's called a hybrid system or system combination. Imagine if you have, in this case, let's say 5 systems which produce translation. Then very often each of the systems does different types of errors, or in other words, makes a section of the translation correct while the other system does not. Now the question is how to combine the outputs of these systems to get correct translation with no repetitions, and actually the one which combines the best parts of all those systems. So far, the big bottleneck of doing this style of translation was the availability of the data. Of course, if you want to train any kind of classifiers or systems that can combine these features, you have to have the outputs of those many systems. And that's what we have been doing, and thanks to the people who work on this type of projects, we now have data available. And at the end of this talk, I will also show how we will call for a challenge similar to the WMT in using those data for improving this type of system, the so-called hybrid systems. The third area that we work on is what we call very broadly context in machine translation. So of course, semantics can be also called in a kind of a context, but in this respect, we mean something broader. So I think someone mentioned, actually, I mean, Josef mentioned that one of the challenges is, for example, to use video or the video of the environment in which people talk, which you want to translate. So we are looking at other things here. For example, topic detection. Topic detection is a thing which can improve translation by way of adaptation of the systems to the particular domain. Now, of course, you can do offline adaptation, which is what people usually do today. But what would be even more interesting would be do some type of online adaptation. When you switch topics, also your models in the translation system will switch, and the quality will stay the same. So there were several groups in our consortium that worked on this topic, on the topic of topic detection. And both in using supervised methods, thanks to the Eurovoc classification and the Europal data, but also work on unsupervised topic detection, which could be very good, especially for spoken translation. So by the way of clustering and using advanced methods from the machine learning community, we can actually get to nice improvements in the final automatic metrics for translation. The last area which I would like to show some results of is data collection and some novel experiments with large data. Now, of course, we probably can't compete with Google, but where we can compete is the quality of the parallel data being extracted from the web or other sources. So at one of the sites, a system has been developed that actually can download data, but most importantly, can identify the parallel sections of the data with high quality, and then use the data for further experiments, especially in the machine translation area. So this is just a diagram of how that works. It looks like a standard system for data collection, but the crucial part is the discovery of the parallel counterparts of the data that have been downloaded. So I promise also to show some of the links. I think we have been hearing here quite a lot about the Euromatrix projects, the Euromatrix and Euromatrix Plus, which actually organize the MT marathons, are running the WMT shared task competitions, and do other things like Josef and especially Stephen talked about. Another project which fulfills one of the goals in Josef's talk is actually FAUST. It's also an EU-supported project which looks at user interaction and fluency of the output. LetsMT, we have actually just heard that LetsMT works also with the Moses system. Accurat is looking at use of comparable corpora. Panacea builds additional resources and tools. And there are also other projects funded by the EC which use machine translation, such as the Kreshmoy project, which is in the medical domain, but uses translation for cross-lingual retrieval and adaptation for that particular domain. So what we are going to do in the nearest future? Well, of course, the research will continue in all these areas, but also we would like to connect with the community, given the success of the open shared task, and specifically in the machine translation domain, the WMT shared task, by issuing challenges for the broader community. So one of them will be the one I already talked about. We have produced data for the output of various machine translation systems, which now people can experiment with in the direction of building a better hybrid system that will take the best of all these individual systems. So this data is now ready, will be issued towards the fall, and then next year there will be a competition period where people will get the test data, will be able to submit results, and the workshop where the results will be reported will be at the Machine Translation Summit 12 in 2012 in China. The other challenge is in preparation, and that should look at re-ranking. Again, this is a technology which has been used, but not so widely. So there will be data for different languages, English and Finnish, and German and French. And this will be, and the evaluation will be automatic. And again, this will be running hopefully next year, also in the spring, and will be reported at the ICANN conference. So this is the immediate future, and I hope I will be able to report on more research results, not only in the challenges, but also in the other areas in which we work within the Metanet project next year. So thank you for your attention.